Welcome back. Today we're doing 7th grade math, chapter 1, lesson 3. We are converting unit rates. Our vocabulary today is unit ratio and dimensional analysis. So again, a unit ratio is the same as a unit rate. The denominator is always a 1. So same idea. Make sure that you cut out and glue tables on top of page 26 into your notebooks. Sorry, I should have started that first. So again, a unit ratio is the exact same thing as a unit rate. The denominator is always a 1. An example here is 12 inches in 1 foot. That is a unit ratio. 16 ounces in 1 pound. That is a unit ratio. 100 centimeters per 1 meter. Unit ratio. Dimensional analysis is the units of measure as a factor, usually diagonally, in the problem that is multiplied. An example would be 10 feet over 1s equals 10 feet over 1s equals 10 inches over 1 foot. We cut out the feet, and we would have 120 inches over 1s. I know that made 0 sense, but it's going to once we get into the example. So let's go ahead and let's ignore this one, and let's get straight into the example of dimensional analysis now that we know what a unit ratio is. So here we have relationships among some commonly used customary and metric units of measure are shown in the tables below. This is the table that we want in your notes. So please make sure you either copy this down or you cut it out. And again, it's in page 26. So the example here would be the numerator and denominator of each of the unit ratios shown are equal. So the value of each ratio is 1. You can convert one rate to an equivalent rate by multiplying by a unit ratio or its reciprocal. When you convert rates, you include the units in your computation. The process of including units of measures are as factors when you compute are called dimensional analysis. So here's the example that we had earlier. 10 feet over 1s would equal 10 feet over 1s times 12 inches over 1 foot. It's kind of the same thing we did last chapter, where the feet would be opposite of each other, and then we'd find out a relationship, a causal relationship. So the s in this case would be second. So let's say that something can move 10 feet per second, which is what we had on the notes. So let me go ahead and walk you through this. So this is 10 feet per 1 second. The causal relationship here, or the dimensional analysis, would still be 10 over 1, again, feet in seconds, but we'd be multiplying it by what 1 foot equals, which is 12 inches. Okay? What we would do then is we're going to ignore the measurements, and we're just multiplying straight across, which would be 120 over 1. So basically what it's saying is it's a dimensional analysis. If I'm saying that something can move 10 feet per second, it's the same thing as saying it can move 120 inches per second. Now I know that sounds weird, and we're like, why the heck would I need to know that? Like, when on earth would I need to understand that? Well, let's find out. An example. A remote control car travels at a rate of 10 feet per second, which is exactly the example we just had. How many inches per second is this? So if you wanted to know how many inches your remote control car went in a second, this is where it would show up. Now I know you're going, the heck, why? Because we need to learn this. So bear with me on this one. So again, we said that this car can move 10 feet per second. We want to find out how many inches that is. So we are putting 10 feet over 1 second times our unit rate, which is 1 foot. And for every 1 foot, there's 12 inches. Same kind of idea. The feet are diagonal from the last chapter when we did a unit rate like this, or our ratios when we try to find these out. So we would ignore the feet, we'd multiply straight across 120 inches per second. So 10 feet per second equals 120 inches per second. Again, I understand it seems a little bit, contrived, but bear with me. A swordfish can swim at a rate of 60 miles per hour. How many feet per hour is this? So again, we start with our unit rate, 60 miles per 1 hour. Now I'm going to go ahead and do this on the board with you. So again, a swordfish can travel 60 miles in an hour. And notice that I put MI for miles instead of M because M stands for meters, so I want to make sure I'm putting the correct measurement. Again, we would look at our table for the causal relationship. 1 mile equals 5,280 feet, and I believe that's what they were asking us, is how many feet per hour is this, is which they did. So I would write this as 60 over 1 times, and again, we want to know what 1 mile is. The mile is down here, again 1 mile, and it would be 5,280 feet. This is per second, this is also miles, but again, we're going to ignore these. We're going to multiply straight across. This will give me 1, and 60 times 5,280, going to use a calculator for this, 5,280 times 60 would give me 316,000, and I believe that was 800 feet. And let's go back and look, and again, since this is over 1, it would just be 316,800 feet, and I'd write it per hour. And I'd write something even more. The swordfish can travel 316,800 feet per hour, something like that. A swordfish can swim at a rate of 316,800 feet per hour, and that would be your appropriate answer. Marvin walks at a speed of 7 feet per second. How many feet per hour is this? So we're going to use the 7 over 1, which is a second 7 feet per second, and we're going to multiply it by 60 seconds over 1 minute, if this makes sense, because we want to know how many feet per hour this is. Why are we multiplying by that? So you can use 60 seconds equals 1 minute, and then you can use 60 minutes equals 1 hour to convert the rates. All right, well, I'm going to walk you guys through this while I walk myself through this. So again, all right, so some of us may get confused by this, but I understand why. Remember, he's walking 7 feet per second, not per minute. So it's not like I can put 1 hour over 60 and just multiply these together. That's not how it works. So I would have to multiply it by the minutes first. So let me walk you guys through this one, because I'm starting to understand it. And I know some of us are looking at it like, the heck just happened? So they walk 7 feet per 1 second. Okay? We're trying to figure out how much they can walk in an hour. Notice that this is seconds, not hours. Therefore, I can't just put hours up here and multiply straight across. Not going to happen. The first rule is they need to be the same type of value. So I'm going to multiply this by 60 seconds first, which means 1 minute. I need to do this first, and then I can multiply it by 60 minutes per 1 hour to find out. So that's the same thing as just saying this. 7 times 60 times 60, and then 1 times 1 times 1. along the bottom. So again, he walks 7 feet per second. I would need to find out how many feet he walks per mile first, per minute first, in order to find out how much he walks in an hour, if this makes any sense whatsoever. So again, if he walks 7 feet per second, runs 7 feet per second would make more sense. 7 times 60, because there's 60 seconds in a minute. He's running 420 steps per minute. I have to find out how much he runs per minute because I can't immediately just convert this to hours yet. So if he walks 420 steps per minute, now I multiply that by 60, and I will get 25,200 steps per hour. 25,200 per hour. Now, let me walk you guys through this again. He walks 7 feet per second. I can't change seconds into hours because there's no unit rate there. 1 hour does not equal a certain kind of seconds. If there was that on the chart, we could totally do that, but this does not have it. And we also don't know it. So there's 2 ways you could have done this. Number 1, you could do it the way they have here, or you could have found out how many seconds there are in 1 hour and then just multiplied these this way. Now, if I want to do handy dandy Google, how many seconds are in an hour? 3,600. 3,600. So you could have set it up, in retrospect, you could have set it up like this. And this would have been seconds per hour. That's one way you could have done it. And then let's look and see. This would have been 7 times 3600, which would still have given me my original answer of 25,200. But we didn't have that information at hand. We just have the information that we know. So again, what I did was I converted this to seconds per minute. Found out by using my calculator that 7 times 60 equaled 420. So I know that he walked 420 feet per minute, and then multiply that by 60 because there's 60 minutes in an hour. And it would have given me this. And hopefully I didn't lose you. Hopefully that made sense. That even confused me a little bit when I saw it, but now it's starting to make sense. So let's look at another one here. Marvin walks at a speed... Wait, no, that one's the one that we just did. That one's the one we just did. We're going to ignore that one. Let's do this one. A gull can fly at a speed of 22 miles per hour. How many feet per hour can the gull fly? So let's start off our question by writing down the first thing. And that is that a seagull can fly 22 miles per hour. 22 miles per 1 hour. Okay. We're going to go ahead and close that, and we're going to close that. About how many feet per hour can the gull fly? So we are going to now figure out the miles go here, feet go here. We want to find out the relationship between feet and miles. And we're going to see if our chart has that. And if it does, cool. And if it doesn't, we're going to have ourselves a little bit of a multiple step one. And unfortunately, it's right here. 1 mile equals 5,280 feet. 5,280 feet per 1 mile. So again, our seagull flies 22 miles per hour. We want to find out how many feet that is. So if 1 mile is 5,280 feet, 22 miles, we're going to multiply it by that. This will be 1. 1 times 1 is 1. And we're going to deal with our calculator here. 5,280, 5,280 times, so again, that's how many feet are in a mile. Again, this seagull flies 22 miles per hour. So I need to find out how many feet there are in 22 miles, and that would be 116, 116, and 160. So it would be 116,160 feet. And that's how much the seagull can fly per hour. And again, my answer will be in sentence form. The seagull can fly 116,160 feet per hour. So, and then here's another example here of another one of 10 miles in 1 hour. They want to find out how many feet per second the speed is. We would have to multiply it to figure out the feet and seconds. So you see there's multiple steps here. So we use the 10 over 1. So again, the average speed of one team in a relay race is about 10 miles per hour. What is their speed in feet per second? So we put 10 over 1 hour. We're going to multiply that by 5,280 feet in 1 mile. So we have to do this multiple step thing. So if they're traveling 10 feet per hour, we want to find out how many feet they're traveling per second. We're going to be doing a lot of different things. So 10 miles per hour times 5,280 feet per 1 mile. That's our first step, is we're going to try to figure out how many feet they are running per hour. When we do that, that'll give us a grand total of 10 times 5,280. So the team's running 10 miles per hour. They are also doing 52,800 feet per hour is what they are doing. Now what I need to do, and you'll see these get switched over, is now I would figure out if they're doing 52,800 feet per hour and we're trying to figure out per second, I'm going to divide this by 60 because there's 60 minutes in an hour, which would mean they're doing 880 feet per minute. And then I have to divide it by seconds, which is 60 seconds in a minute. So they're doing roughly 14.66666 forever, or roughly 14.7 feet per second. Now, that's me walking you through the step-by-step analysis. What they want you to do is to just multiply straight across and have an entire ratio, which will still give me the same answer. Now, I know some of us are like, the heck just happened? If you get lost by this, it's a very good idea that you watch the live teaching in class so you can ask questions. So let me walk you guys through this one last time, and we will hopefully make sense of this. So the question again is, a relay team can run 10 miles per hour. That is their average. 10 miles in 1 hour. Our goal is to find out how fast they can run in feet per second. So we want to find out how many feet for each second. Now, I can't convert 10 miles per hour straight across. I can't. I need to first convert that miles into feet. So I'm going to multiply it by 1 mile, which equals 5,280 feet, if I'm not mistaken. Okay, so again, in order for me to convert this team's miles per hour into how many feet per second, I have to turn those miles into feet, and then I'm going to have to turn that hour into a minute and then into seconds. So my first deal here is to multiply straight across, because this is going to tell me that this team is running 52,800 feet per hour. That's my first step, because again, these will go away, the feet will stay, and the hour will stay. So This team is running 52,800 feet per hour. But again, I want to know how many feet they're doing per second. So the next thing I'm going to do is to divide it down to where I can figure out how much they're running per minute. And then I will divide that down per second. Now, instead of dividing, I'm just going to multiply by the reciprocal. So 1 will be on top and 60 will be on bottom. Because remember, there are 60 minutes in an hour. The hours will cross apart, and this will now give me 52,800 divided by 60. 52,800 divided by 60 will give me a total of 880. So they're running 880 feet per 1 minute. That is what they're doing. Now I need to find out my seconds. So again, I'm going to multiply it across, but this again, 1 will be on top because I want to find out how much they run per second. This is minutes, which means the minutes will cross out, and there are 60 seconds per minute. This will give me 880 divided by 60. 880 over 60, which I should have written over here is 52,800 over 60. When I divide that, 880 divided by 60, I will get 14.66666 forever and ever, or about 14.7 seconds. So this team that runs, or not, sorry, not seconds, feet per second. So this team that runs an average of 10 miles per hour is actually doing 14.7 feet per second. That was a nightmare. Because I know some of you were like, I don't know what happened. So again, questions, comments, concerns, pay attention to the live teaching in class. You guys are always welcome to reach out. I know that was a lot in this lesson, but this is the end of that lesson. So again, if you are still confused, watch the live teaching. As always, this is Mr. P, and I will be signing out. I will catch you guys on the next one.